Hello, my name is Khizr and I will be doing the last demonstration of this project. As Saeed showed that we were able to deploy the containerized application to the Swarm cluster and we were able to scale it up to 6 replicas. Depending on the hardware available, we can scale our application to as many replicas as we want, and the Swarm will automatically and intelligently distribute the replicas on the nodes that it has. As we can see, currently we have 3 nodes and we have 6 replicas evenly distributed on the 3 nodes. I will now demonstrate how we can do CI/CD, continuous integration, continuous deployment, how we can update an image and deploy a new version of the image on the same Swarm cluster. This is critical in enterprise environments where you have to deploy new revisions of the application very frequently. So the first thing we'll do is we will update our image. We'll make a change in the image and we will upload the change to our Docker Hub. For this, we will log into the virtual machine in which we first created our containerized application. So now we are in the machine in the same virtual machine where we created our first image and uploaded to Docker Hub. We will go to the HTML folder where we have our Docker file. If we look at the Docker file, we can see the Docker file still exists and all the steps that we mentioned for creating the Docker image. So now I'm just going to run the Docker build command just to make sure and just to demonstrate that this is our latest image and there are no changes required. If I do that now, if I run the Docker build command with the same tag, username / the project name and the version latest, we will see that there are no changes. And if we push the same image back to Docker Hub, we will see that Docker recognizes that the digest is matching and it will say that the version is updated and it will say the layer already exists. And there will be no upload because there is no change, there are no changes uploaded yet as of now. So Docker reports that our image is up to date. And so we are in the current version without any changes. So what we're going to do now is we're going to make a modification to our application just to demonstrate how we can apply and how we can deploy new changes or new revision of our applications. So I'm just simply going to open the SQL dump that we created and I will just change the title of our front web application. As we can see in this SQL dump, in this table, there is this title of our application or the blog name, NSA 713 final project, and we will apply a change. Demo version. So I have changed the title of the application. So now our application should be changed. I will now upload this image but with a new version tag. I will use a demo tag. Docker by default uses the latest tag, but this change that I'm applying, I can give it any tag, any arbitrary tag. So I'm giving it a demo tag. So Docker will now rebuild the image with a different version. So our image is now built. And now we can push this new version, the demo version, to our Docker Hub account. We will add, before when we were pushing the image, we were not using a image version tag. In that case, Docker assumed the latest tag. Now since we have applied a new change and we want to push that image as a demo version tag, we will do the same. We will mention the demo tag while pushing the image to Docker Hub. This time Docker should see that there are changes, and it should see the sum of the layer changes. We can see that 3 layers were not changed, but there were 2 layers, actually 3 layers changed. So the Docker will only upload those new layers and give us our new version of our application. So our new image has been pushed to Docker Hub now with the demo tag, and the changes that we wanted to make are in this demo version. Now we don't need this virtual machine. We can actually power it off. So now we are back to our Swarm cluster, where we have deployed the latest version of our application, which is running in this web browser as of now. Now what I'm going to do is I will instruct the Docker service to update my service with the new version, and I will say that instead of using the latest version, it should now deploy the demo version. I have to mention the service name. So now running this command will instruct Docker Swarm to update my service, which is already running with the image NSA 713 project latest version. It will update my service to move to the demo version. Docker by default updates the image one by one. So as Saeed deployed 6 replicas, we can now see that Docker Swarm will update our image, our service one by one. So currently it's preparing node 1, replica 1. So it has to now download the new image with the demo version tag from Docker Hub. If we go to Docker Hub, we can actually see that we now have a demo version available. This new version was tested a while ago. This is not required. So now this was updated 2 minutes ago. Now we have these version tags. Docker is currently running the latest version, and we have now instructed it to run the demo version. So as soon as it's prepared, okay, we can see that Docker has one of the container is updated, and it's now preparing the second node. If we open a new terminal while this is happening, and we SSH it into Docker 1, and we do Docker service PS test. Sorry. We can see that the node 1, the first replica, has been updated to demo version. It's no longer the latest version. It's the new version that we instructed Docker to update to. Other versions are still running latest. Docker is now orchestrating the whole process of updating this CI/CD pipeline, where we can apply changes automatically as they are pushed. If we run this again, we should be able to see that more replicas are now in demo version. We can see that there are at least 3, 1, 2, 3, and 4 So what Docker is doing is it's shutting down the old Docker images, and it's creating new containers with our required version. And this is done without any downtime, because Docker, if we now visit our Docker, we can see that our application is on the demo version. This is the change we did in the MySQL database. And we can go to any node, and we can any of the 3 nodes, and we should always land on the demo version, because this is the current state of our service. So now if we run Docker, here we can see the Docker has updated our service on all 6 replicas. And if we run Docker, if we check, now all of our replicas are running in the demo version. The latest version have been shut down. Now, as we see, it was just a simple update service command for our application to move to a different version. We can as simply as this roll back. I will demonstrate how we can roll back our changes that we applied. So let's suppose that changes that we applied on our service were not desirable, or we want to roll back for any reason. We can simply run Docker service rollback, and Docker will take care of this. Docker intelligently knows that what changes were applied in the last update, and it will roll back those changes. So Docker will now roll back the changes that we applied on all 6 replicas. It will take a few seconds. Docker is doing this step by step on one replica at a time to avoid any disruption of the service. So now all 6 of our replicas have been rolled back to the previous version. So if we now visit our Docker port 80 service, we should see that we are back on the original NSA 713 final project without a demo version tag in the title. And we can go to any node, and we should see that we are on the current version. So this is how we can apply rolling updates, and we can do blue-green deployments. In terms of blue-green deployments, we can deploy a new version on a different port. So instead of creating a service, we can create a service on port 81 and deploy a demo version on port 81 and test it on port 81, and then move this service to production. This can also be done. This is the whole idea of blue-green deployment, that we deploy a new service on a different port, on a different service name, and once our application has been tested, we can then move it to production. That's it. Our Swarm cluster is up and running. We can play with the number of replicas that we have. For example, we can update our service, and we can ask Docker Swarm cluster to reduce the number of replicas to 3, and it will just kill 3 nodes, 3 replicas, 3 containers, and we will be down to 3 containers. And as you can see now, if we do a Docker service PS of our test service, we should see that only 3 containers are running and all others are shut down. Let me grab this. So we can see that only 3 services or containers are running, and all 3 of them are distributed evenly on the 3 nodes that we have. So this was the complete demonstration. We went from creating a legacy application that was a standard WordPress application. Then we containerized the application by writing a Docker file. We created a Swarm cluster, and then we use this Swarm cluster to deploy our containerized application. We can apply changes. We can create a CI/CD pipeline. We can apply rolling updates. We can do blue-green deployments on the Swarm cluster very easily without disrupting. And Docker Swarm cluster handles most of the orchestration and automation behind the changes that we need, behind the revisions that we need to deploy. That's it for the project. Any questions?